Good stuff. Okay. Right. It's 9 o'clock on the 8th of February. Welcome aboard, everyone. This is day 2 of GSE UK virtual conference, and this is day 2 of the DB2 stream. And I'm very pleased to announce that this morning we have Marcus Davidge from BMC, my co-chair for the DB2 stream, presenting the session Express Yourself. And without further ado, I'll hand over to a frozen Marcus who's just cleaned the car of ice and is trying to warm up. So I hope your fingers are working. I'll pass over to you. Good luck.
Thank you very much. So thanks everyone for joining, and I'm sure more will join soon. I will turn my camera off just to improve the bandwidth. But thanks for joining. This is my session called Express Yourself on regular expressions on the mainframe and how they can be used in ISPF, in TSO, in DB2. So let's go. So here's the agenda for the next few minutes. About an hour then, really, isn't it? Introduction, what are regular expressions? We shall go into their terminology and some examples, how they can be used in ISPF, in DB2, the support that IBM have provided for REX, a little ninja school for regular expressions, and a practical usage at the end. So hold on, if you can manage to last until the end, they will be a very practical example of how you can use them. So a regular expression, or regex, is a sequence of characters that define a search pattern. They've been around since the 60s, but only recently have been adopted more ubiquitously across platforms. This session hopes to enlighten the user to the history, use, and implementations of regular expressions and how they can be used in DB2. So regular expressions are a way of specifying a string for pattern matching. They've been around since the 1950s in maths theory. In the 60s, they were used in Unix, and in ZOS have been around since 2.1. By using meta characters, and I'll explain what those are in a minute, regular expressions are a flexible and powerful way of specifying patterns. They can be cryptic, non-intuitive, and time-consuming to create and debug. They can be CPU intensive to process, and if poorly specified, can affect system performance. Different computing platforms and programming languages may implement slightly different flavors of regex. So Python, Perl, Java, ISPF, DB2 XML queries, .NET, PHP, blah, blah, blah. This sounds like there's nothing good about them, but they are very, very powerful. So how do you use it? If you're in Unix, got a nice little Unix command line up, you can run Unix on your Mac or in Windows subsystem for Linux on your Windows machine, or if you've got a Linux machine, it comes out of the box. So this is how you use it. That's the grep, get regular expression command. So if I typed in egrep standby push, so that's my regular expression. Just a minute. I wonder if I could spotlight. There you go. Can you see that? Yay. So this is my regular expression. This is the file that I'm searching for. I'll bring that back. That was quite useful. Where's it gone? There. So looking for Llanfair Pwll will actually bring back Llanfair Pwll Gwyngyll, because it appears in the first few letters there. And it would also appear in Llanfair Pwll Gwyngyll Gogerych Wyndralwodd Llantysilio Gogogoch, which is the longest place name in the UK, the third longest in the world. So what I could do here, I'm echoing the word string, or I'm echoing a string, and I'm piping the output into egrep, and I'm looking for a regular expression. So, for example, I'm echoing, or I'm outputting the phrase tonight, the British spelling, tonight, the American spelling, and tonight, a ridiculous spelling. And I'm looking for this pattern. So I'm looking for words that begin with T-O-N-I. And I'll explain what these mean a little bit later on. But it's only matched the first two. It hasn't matched the second one. So let me explain a little later what they mean. So regular expressions are callable in programs using common libraries. So whether you're writing C, C++, Java, Python, we've all got libraries for regular expressions. So what's the terminology? What are these meta characters? So within a regular expression, the caret, or the up arrow, the little hat as we call it in Welsh, represents the start of a line. The $sign represents the end of a line. A full stop matches any single character. A bracketed expression matches any single character within the brackets. The same thing, but with a caret in front, matches any single character not contained within the brackets. These parentheses represent a character group or sub-expression. Oops. And a vertical bar means an or. So it matches either expression, either side of the vertical bar that it separates. Okie dokes. So some examples. Dot, if you remember, matches any 3-character string with that ends with AT. So dot AT would match hat, cat, and bat. Fairly simple. D.G matches any 3-character string starting with D and ending with G with one character in the middle. So dog. Square brackets HC, AT would match hat and cat. So the square brackets represent one character, but it could either be H or C, and it must be followed by AT. So that would match HAT and CAT. If you remember, the round brackets, the parentheses, that represents a group, and a vertical bar means an or. So this expression would match hat or cat. And the brackets with a caret sign in front means match everything ending in AT except bat. And in the practical example at the end, you will see this in action. So here we've got more than one character after the not sign. So this would match all strings matched by something AT other than hat and cat. Now, if we move the caret from inside the square brackets to outside the square brackets, its meaning has now changed to mean the beginning of the string. So this would match hat and cat, but only if they appear at the beginning of the string. So if C or H were the first character of the line. I should put my own phone on Do Not Disturb. The last one, we've got $1 at the end. So this matches hat and cat, but only if that word appears at the end of the string or the line. So some more terminology. If we provide an X with a question mark, that means that the X is optional. The plus means that X appears one or more times. The star, the asterisk, means that X appears 0 or more times. The brace with a number M means that it appears M times. M comma N means it appears between M and N times. And M with a comma but no N means that the letter or this character appears at least M times. So examples: S dot asterisk matches the letter S followed by 0 or more characters. So for example, it would match S, the letter S. If that was any string containing S, it would match. It would match the word see, saw, seesaw, and sphygmomanometer. And where else would you get a presentation with Llanfair Pwllgwyngyll, Gogerach yn Robot, Llantysilio Goch, and sphygmomanometer in the same session? Here, square brace, capital Q and small q. This matches any line with a capital Q or a small q. This expression would match any line with a big Q or a small q that is not followed by a U. So it would bring up Iraqi, QI, but not Iraq, because the Q of Iraq is the last letter, and this maintains that the Q must be followed by a letter, but it's not. It can't be followed by a U. Here, caret M means M must be the first character. It can match 2 or 3, between 2 and 3 characters of E, A, I, and Y, and it must end in an N. So it would match main, mean, and mayan, because they are between 2 and 3 occurrences of these vowels, but it won't match man or men, because I'm specifying it must be at least 2 and no more than 3. Here, I'm asking for it to match an M as the first character, an N as the last character, and 2 in exactly 2, any 2 of these, so that it would match main and mean, but not mayan, men, or man or men. So here, I'm looking for J, capital J, U, L, and 0 or more optional Ys. So it would bring up July and Jule, but because there's no end clause, it would also match Julienne, because there's a J, U, and an L, and there's nothing after it. For our American friends, here I'm looking for a capital C, O, L, O, an optional U, followed by an R. So this would match both color and color. one more page of terminology. So I've expressed what a character group looked like, which is parentheses. Vertical bar means an or, so it matches either expression that it separates. A \1 refers to the previous first matching sub-expression, or whatever was in this in these parentheses. \n refers to the previous nth matching sub-expression, and I'll explain what these are in a minute. And just a / is an escape character if I actually want to search for one of the meta characters. So if I'm looking for a caret, circumflex, then I would just do / circumflex, and it will look for a circumflex. So examples. Back to the old one, I was looking for any line with a uppercase Q or a lowercase q that's not followed by a U, but here I'm adding in the parentheses and a vertical bar, an or is at the end of the line. So what I'm now looking for is any line with a Q that's not followed by a U, or is at the end of a line. So this now matches Iraqi and Iraq, because the previous search didn't have the or dollar in it, and it didn't bring up Iraq because Iraq, the Q here is at the end of the line. This is getting tricky now. So / this square bracket dot / square bracket, close square bracket or brace. No, bracket, yes. This matches any single character surrounded by open bracket and close bracket. So these are escaped. So this is the escape character. So I'm now actually looking for open and close square bracket. So this would look for A and B, because that's represented by this full stop. So it's any single character surrounded by open and close brackets. So now we're going on to the reference. So the \1 refers to what was in the group, which is in this the parentheses. So let's go back. The parentheses, this is a grouping, a subgroup, that matches any letter between A and Z. So it's basically any letter. The \1 refers to refers to whatever was in here. So basically this expression matches any doubled letters. So that would match Jenny Lee, or Jenny, because it's got two N's, Jenny Lee, because it's got two N's and two E's, Llangollen, because it's got two lowercase L's there, but not there. It wouldn't match Aardvark, because an uppercase and a lowercase a appears, and it wouldn't match Llanbedr, which is has an uppercase and a lowercase L. So because it says here, I'm looking for lowercase. Let's have a look at this one. So I am now matching, I'm looking for any doubled words. So plus means, oops, let's go back, sorry. Let's go back a few to see if we can remember what plus means. Oh. No, I've gone too far, sorry. There we go. Plus appears one or more times. So let's go back to where we were. Right. So here I've got an expression A to Z, so it's any letter. Plus means it occurs one or more times. So that's basically any word. Then that's a space. And the space occurs one or more times. This is a reference to what was before, which is whatever was matched in this bracket. So if I'm looking for double words, then that would match any doubled words, because I've got any. Any is the word which is matched by this expression. There's any number of spaces in between them, and this refers to the first subgroup, which was the word here. So that would match any doubled words. Right, final page on terminology. Backslash lowercase d means any digit. Backslash uppercase d means any non-digit. Yeah, you can read that for yourself. This is quite handy, a new line, if you're actually looking for something at the end of a line. I actually use this \n if I'm editing some code in Visual Studio Code, because that's got a nice little regular expression search, and I want to replace a new line with, or two new lines together, and I just want to replace it with one new line or none at all, which is great if I want to do a text flow kind of thing. So in the following text, Ganymede, he continued, is the largest moon in the solar system. The expression HE would match Ganymede, he continued, is, and there's a HE in the largest moon in the solar system. But this \b means a full word, or this expression is another way of expressing a full word. So that would only match the he as the full word there, and it would ignore the HE in the word the. Okay, got that? There you go. So let's have a look at how regex is implemented on the Z platform. So it has its own differences, idiosyncrasies. The meta character \d, which is any decimal, doesn't exist. It's not been implemented in ISPF. It's been replaced by the range 0 to 9. \D, which means any non-digit, has been replaced by the opposite, any non-number there. So any, yeah. \W means any word, has been replaced by any lowercase or uppercase. Not a word has been replaced by the opposite. Here, \S, which is a space, has been replaced by a space, and so on. However, this is nasty. The dollar is has not been implemented correctly, in my opinion. It does exist and it does work, but unfortunately in ISPF, you can specify nulls on or nulls off if you're editing. If you want to look for something that's at the end of a line, it would fail unless you use, I'm looking for any number of blanks before the end of the line, because you want to trap 0 or more trailing spaces. I shall show you what that means in the next session, next slide. So within ISPF, I don't know whether you've seen these options in the find command before, but I'm sure you've all used fstring, find string. This is case insensitive. find capital or find T before the quotes, you're looking for text. That's case insensitive. If you find, so F space C quote and then a bunch of characters, this is case sensitive. What ISPF has implemented is a find R, and then within the quote, the single quotes or double quotes, is the regular expression. That's case insensitive. So it ignores whatever case you're looking for. And a combination of R for regular expression and capital C or C for case sensitivity. So you get F space RC quote regular expression, that becomes case sensitive. So here's my word list. I've got llama with a capital L, llamas with an apostrophe S, llamas without the apostrophe S, but just an S, and then the same as above, but with a lowercase l, just to show the difference between these functions. So find llama is case insensitive. So it will find all occurrences of the word llama, whether it's got uppercase or lowercase in. So yeah, you've all seen this before. I'm sure you have. I'm looking for text llama, and this is also case insensitive. Find C llama. So C, I guess you could say, rather than character, call it case sensitive. I'm sure there's a meaning for it. So find C quote llama all would only look for the lowercase l's. So it matches there exactly what I was expecting. Find C uppercase llama, as you would expect, only finds these. So that's quite handy. Thanks, IBM, for bringing this in. Now I'm looking for a regular expression. I'm looking for the regular expression llama, which is my search expression. And there it is. It's found everything because it's case insensitive. Now, if I wanted to find the characters apostrophe S, I would use this regular expression. So find R for regular expression. I use a double quote because I'm looking for a single quote and I don't want to get ISPF all confused and everything. I've got an escape because I'm looking for a meta character, which is the single quote. And then I'm looking for an S. So I'm looking for apostrophe S. So this is how I express that in a normal regular expression. I want to do find that all. Hooray, I found llamas with a capital S and llamas with a lowercase s. So that's how you use regular expressions in ISPF. What if I wanted to find an apostrophe S at the end of a line? I would put the dollar there, but it's complained there are no characters found. But there are 80 odd, well, 70 something trailing blanks here, and regular expressions hasn't matched these because they are trailing blanks. This isn't the end of the line. ISPF or ZOS doesn't implement hex zeros, as the C language does, as the end of a line. So what do we do? I'm looking for the end of a line that's preceded by 0 or more trailing blanks. And now it's found this one and this one. So that's how you get around the dodgy implementation of the end of the line marker here. So here's an example. my research requirement is I'm looking for variable definitions of type char in a C program. So here's my snippet of the C program. I'm sure you've all seen the SQLCA before. This is its implementation in C. So I've got the SQL code, the SQL error message, SQL ERP, and the 5-6 different variables of ERRD. Then you've got the warning message and the SQL state. So variable definitions of type char in a C program, basically looking for anything that matches which is highlighted. So that's what I'm looking for. How do I find that? So find the word char, all. The first occurrence on line 1 isn't a variable definition. It's a parameter definition. So that's not good enough. I'm now looking for open brackets. And yeah, it's found these two, but it's also found these later on. So let's bring in regular expressions. I'm finding the regular expression square bracket followed by any number of digits followed by a close bracket. And lo and behold, it's got 71 here, it's got the 9 here, so any number of digits. Okay, so that's worked. So let's expand that a little bit. I'm looking for the letters CHAR, so here, followed by at least one letter or space. So here we go. Lowercase a to z, uppercase a to z, and here's my space. Oh, I just clicked on there. Here's my space. So followed by at least one letter or space. I've done them in nice little color coding to make it easier to read. Followed by an open bracket, which is the gray one. Orange, followed by at least one number, which is the bracket 0 to 9, close bracket plus, followed by a close bracket, which is here. So this doesn't include numbers or special characters in the variable names, but you get the gist. So it has actually matched just these two. So this is how regular expressions work in ISPF edit. Moving on. How are regular expressions implemented in DB2? Let's have a look at its implementation and idiosyncrasies, foibles, usage, and examples. So Pure XML added regex support in version 9.7 of DB2LUW. And this was implemented via XQuery with the matches function. So, where are we? So I'm creating with val as, so I'm creating a common table expression called val. This is a common table in my SQL statement. And I'm defining val as a text, selecting text from a texts file. And I'm casting, I'm creating an XML query using the matches function. So calling function matches. And this is the text column from the texts table here. So this column matches this column from the text, and it's applying the matches function to the column, and it's looking for well, this basically this string, any number, any letter A to Z with a space followed by any number, and any number of those. And here it's selecting from the result of this in the common table. So that's how it was implemented in DB2 LUW version 9. In version 11, IBM added built-in regular expression support with the following functions: pattern matching, counting or locating a pattern, which returns a numeric result, and extracting or transforming a pattern, which returns a string. So this returns Boolean, true or false. This returns a number, and this actually returns a string. So, for example, here's my common table expression, and I'm looking for, I'm populating my common table expression with some values. PO Box 1, PO Box 2, and as you notice, these are all variations on a format. But I'm actually looking for this one, so I'm adding this one into my common table because this is the one I'm looking for. So I'm selecting a street from cust, my common table. We're not regex like, so I'm not looking for this regular expression, and I is case insensitive. I is case sensitive, and it has matched what I'm looking for. So I'm just basically showing you this. Here's your regular expression, the meaning of which we've done earlier, and this is how you code it in LUW. So first, DB2 for ZOS. XML added regex support in DB2 10 via xquery with the matches function, but there's still no built-in support yet. However, LUW regex functions are available in IDAA as a pass-through in version 7.17 of IDAA as of April 2019. Unfortunately, it's CPU intensive, excuse me. Regular expressions are stage 3 predicates, so they're non-indexable. They do perform a sequential scan of your results set. So please make sure that you've reduced the result set as much as you can using proper indexed and predicates before you invoke regex, because regex will scan the result set. So, for example, select name DBID from sysibm.sys database, no predicates, and that's a lot. If I wanted to match databases that begin with DSN and that are followed by 0 or more characters, but they must end with a 0 to 9 or a numeric, this is what I would do. So once again, I've color-coded my clauses for clarity. Oh, I like a bit of alliteration. Color-coded my clauses for clarity. So I want to match databases that begin. Here's my caret, my circumflex, to denote the beginning of a string. I'm beginning with DSN, the characters DSN. So this is my group, DSN, followed by 0 or more characters. So here's the star meaning 0 or more, and dot means a character. But it must end, yellow, so here's my dollar, with a 0 to 9. So here's my 0 to 9 clause. So how does that look? The XML function matches only takes XML as input. So what I have to do is create an XML document using the name column content from sysibm.sys database. And then I create that XML document using the xquery constructor. So orange name, this is the name of the column from sys database. So your sysibm.sys database. So I'm passing name as name col this is the variable name that I'm attaching to the column name. So name call is referred to here. And in this line here, I'm creating an XML document. So tag doc, and there's my tag /doc to specify the end of the document. There's a brace there and a brace there, denoting a repeating group, a dollar denoting a variable, and the variable name is being inserted by whatever is passed from my query and outside query here, selecting name from sys database. So the XML query creates a document. Sorry, this structure creates a document and passes it to the XML query function, calling it new doc. And I'm looking for, right, yes, so we pass the constructed XML, call it new doc as input to the FN matches function. The second parameter of the function matches function is a pattern we search for. It supports regular expressions. So feel free to use this as a template for any XML based selects from the catalog or from your tables. And also you feel free to use it if you want to work out how to do regular expression searching on DB2. I've tried to make it color coded to make it as easy as possible to deconstruct. But here's the result. Databases that begin with DSN followed by 0 or more characters. So here I've got DSN DB, so it's a character, but 0000 is are also characters, but it must end with a 0 to 9. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 1, and a 0. Fine. However, you can also use the same format as the pure XML query from LUW, except you must use the passing clause as follows. Once again, I've tried to color code it. So I'm creating a common table here called val. The column text from the table texts is in gray. I'm passing text as variable v, and I'm passing variable v into this matches expression, and I'm searching that text column from the text table with this regular expression. That comes back as an integer, true or false, and I'm just returning everything from text table. So regular expression support in Rex and its embarrassing lack of existence. So this is how IBM have implemented regex support in the Rex programming language. It hasn't. Sorry. Martin Packer, however, performance expert for IBM, who is probably currently presenting as we speak on another stream at the GSE conference. He's put up some of his own stuff in GitHub, also on his own page on DeveloperWorks, or whatever that's called now. I think IBM have reinvented it. Also, if you have a look at the IBM Knowledge Center, there is a BPXW Unix function in Rex that you could use, but it's not fun. So basically, there's no user supplied, or there's no IBM supplied support for regular expressions in Rex. So a few pages on what I call Ninja School. Firstly, performance. Like any SQL, how you code a regular expression has impact on its performance. So let's try and optimize our regular expressions like you would optimize your SQL. To match the words tonight, English spelling, tonight, American spelling, or tonight with, yeah, it's a portmanteau. And I'm looking for those words in the phrase hot tonic tonight. You could specify the following search expressions. This is my regular expression. I'm specifying complete words. Fine. Tonight or tonight or tonight. This is basically bad. Now I'm removing the first commonality, which is TO. Each one of these three words begins with TO, so I could move that to the beginning. The rest, I can specify NITE or KNIGHT or NIGHT. But now I'm removing the second commonality, NI. NI appears in here, or in this word, and this word. So let's remove that. So TO, NI, and NI can be followed by GHT or TE. Or I'm looking for KNIGHT. But NI is still exists in here, so let's see if we can remove that. So here we go. If I look for K2 followed by an optional K followed by NIGHT, it will bring up this one or this one. Or if I look for TO followed by NITE, it will bring up this one. Okay, so we are getting there. Now let's remove the third commonality of NI. So I'm implementing what I've done here with this bit, and I'm bringing this down here. So I've now got the letters TO, followed by an optional K, followed by the letters NI. Oh, I keep pressing. Right. Followed by an optional NI, followed by either a GHT or a TE. Further simplification is this. So TO is required. K is optional. NI is required. GH is optional. T is required. E is optional. This would match all of these. So as you see, I'm reducing the complex. Well, it looks complex, but I'm reducing the processing that the regular expression function has to go through in order to apply this expression to the search algorithm. So skipping through the next few pages, you can read this later if you want, because this can be quite deep. And I know I'm being, yeah, I got about 10 minutes left. So let's jump forward a bit. Ninja School, this is quite deep. Please have a look at these yourself in your own time. A greedy result means you're bringing back as many as possible. A docile means you're giving back when needed. Lazy or reluctant search means you're bringing back as few as possible, so it's the shortest match. There's something called helpful. With a lazy qualifier, a lazy quantifier, the engine starts out by matching as few of the tokens as the quantifier allows. So this is quite, yeah, helpful. There's something called possessive. So this gives up characters if needed in order to allow the rest of the pattern to match. Or you've got something awful, which is called explosive or exponential or catastrophic, which is infinite backtracking. You can write your regular expression where the potential for backtracking in relation to the length of the string is exponential. So this is hugely inefficient. So if you want to have a look at more, there's a book called Mastering Regular Expressions. And yeah, just a sec. I'll bring my video out. Here it is. So you've got two different engines in regular expressions, the DFA engine, which is deterministic finite automaton, that steps through the input string character by character and remembers all of the possible ways the regular expression could match at this point. If it reaches the end of the string, it declares a success. Then you've got NFA, non-deterministic finite automaton, that steps through the regular expression token by token rather than character by character and tries all possible permutations on the string, backtracking if necessary. It's greedy. It can craft exactly the match that you want, but for all intents and purposes, we're quite happy with DFA, the first one. It's very fast and it's consistent. It depends on the implementation of regex that you're using. Sometimes our hands are tied. You can do if then else constructs. So that looks like this. So if proposition A is true, then match pattern X. If proposition A is not true, then match pattern Y. If proposition A is true, then match pattern X. Otherwise, match pattern Y. You've got something called look aheads or look arounds. You can look ahead, you can look behind. I'll leave these on my presentation, which you can download. Caveat haber, let the architect beware. If you're monkeying around with regular expressions on a 3270 emulator, you must always attune your emulator to whatever code page TSO is using. Yeah, code pages, horrible. Trial and error. You just try it out and see. Not all programming languages or implementations of regex contain the full set of meta characters. I'm looking at you, ISPF. Yeah, once again, trial and error. Know your data. You've got to know what you're looking for before you can find it. Once again, trial and error. CPU. There's no such thing as a free lunch. Regular expressions are very, very powerful, but they're not CPU light. If you're using it in DB2, it will sequentially scan the result set. It's very handy for returning breaches of naming standards. So if you're looking for a date, if you're parsing your DDL and you want to make sure that the database name matches your database standards, like D and then a project code and then some numbers, then this is great for making sure that whatever your standards are, that the DDL matches it. If you want to do refer backs to the Stowe group of a database, DDL, create database, you can refer the Stowe group back to the Stowe group name in the create Stowe group command. Yeah, you can, if there's any other way of doing it, it's very, very powerful, but use it as a last resort. Try like, replace, or translate first. Yeah, your colleagues will hate you, especially if you code something like this. There's a famous cartoon here. I've got 99 problems, so I used regular expressions. Now I have 100 problems. Why I've got 100 problems? Because we've got 99 problems and a solution in regular expressions that nobody can understand. Here are my references. These are available in the download. And so in the last 5 minutes, practical usage. Okay. Who's ever heard of Wordle? So when I did Wordle a while ago, I've given up now. I've got far more important things to do. The first two words that I used in my Wordles were arise and youth. So whatever it was, I put these two in because it included all of the vowels. And it was a good starter, I thought. My wife uses different starter words. So let's have a look. I'm searching, this is my regular expression here. And I'm searching in Linux user share dict words, which is a big collection of words. So I'm looking for the beginning of the word. It's not a Y because this has come up yellow, and it's not an R. No, so followed by something that's not an R. So I know because there is an R, but it's not there. There are other two letters here, dot, dot. So that's dot, dot. And it's followed by a letter that isn't an E. I'm doing a grep minus V, which means it must not match this, because I know that the letters A, I, S, O, U, T, H haven't appeared. And I just want to see how many words there are. So I'm passing this into a word count. So there are 724 words that it could possibly be. But I am looking for an R, an E, and a Y. So I'm passing this output into a grep looking for R. And then of all of those words which have R's in, I'm looking for the words which have Y in. And of all of those words, I'm looking for words which have E in. And I've narrowed this down to 113. So I'm just looking through the output of all of these words which have got all of these letters which match. And here's one. Oh, I'll pick this one at random because that's the one I've heard of. I mean, who's ever heard of these? So I put in reply, hey, I've got two matches. So I now change my regular expression to words that begin with, words that don't begin with, sorry, R and a Y. It does have an E in the second character. The third character could be anything. The next character I know is not an L. And the last character is a Y. So I'm excluding all words which have these letters in, A, I, S, O, U, P, T, H. And I'm looking for words which have G, R, and L in, because I've already specified the Y. So let's count how many words there are. Oh, there's one. So let's remove the count and actually display what the word is. And I think it's Leary. So let's type it in. And there it is. So that's how you use regular expressions to solve Wordles. Thank you for listening. Yep, I'm Marcus Davidge. Please leave your conference feedback. Session was 2F, and have a great day. Enjoy the rest of the conference.
Wow, that's a good way to start off. Hopefully that's made a few brains tick over. Thanks very much, Marcus. Any questions at all? Is anybody dying to try that out? Yeah, I've got a few comments, mind-blowing. Someone else saying interesting topic. Yeah, I've got an absolute perfect application for this. I've been searching for a way of doing something. I think this might just be it. So I'd be eager to get back and try it sometime, Marcus. I'll let you know how it goes.
Yeah, if anybody needs to use this and they thought this was useful, then please let me know.
Right, there's no questions coming in. No, okay, well, thanks very much, Marcus, and thanks everyone for attending. We've got a 30-minute coffee break, and then we're back on straight away in DB2 at 10:30, and that session is all about multi-row operations in a nutshell, from Emil Cottridge from Broadcom. So that's 30 minutes. Get a coffee, come back. We'll see you soon. Thanks very much.
Thank you. Thanks, everyone.